So in the exam, there's no way that I can ask you to run some results, but it is very, very important to get used to this layout. Like now, I assume you know the layout of SAS when the results are from SAS, isn't it? You know, you have an idea of what? Of the layout. Again, if the results are from Excel, you have an idea how the results looks like. But we never used what? We never used the SPSS. But most of my previous papers, the outputs are in what? Are in SPSS. So what is happening with SPSS is a point and click software. This one, no programming is needed. It's a matter of point and click. Whatever you need, you just select. And then, so, like what is going to happen here, SPSS is having two windows. We have a data view window and we have a variable view window. We have two windows. Data view window. If you see at the bottom here, when I click this one, it says data view. Means yeah, that this is the page where you'll be seeing your data set. Variable view. This one, if you can check even the heading there on top, is it needs the name, the type of the variable, the width, how many decimals, the levels. I will explain the difference there. I will use the class example to explain this. So this one, if you can check up there, is written var up to and there up to the last one. So this var will change if we define a variable on this variable window. When you go back to data view, you'll find this var what with that name that you wrote on the other page. For example, based on our class example, we have how many variables? We have the selling price of the house. What else do we have? If I go back to the to data view, you see now the selling price is there because I defined my first variable. What is the other variable that we have to define? Is the age of the house. Another variable that we have to define is the size of the house. Is the size of the house. But with this other additional information, it's asking you that you are saying you have the selling price. Is the selling price a numeric? So I'm not sure if you are seeing this page. There's a page that will pop out. If you are in front of the laptop, please click on your far right next under the cell of type. You will see three dots there. When you click those three dots, oh sorry. When you click the three dots, or it means I was supposed to share the window, not the screen. Let me share the window, guys, not the screen, so that you can also see the other options. I have to share the screen, the window. Can you see this additional page that is appearing now? When I click the three dots, can you see this window, guys? Thank you. So it will ask you what type of a variable are you having? Is it a numeric? Is it numerical? Is it a numeric variable? Is it categorical? Is it having commas? So if it's a categorical variable, you have to select what? You have to select a string. If it's categorical, you select a string. If whatever you're capturing under that column is the date, you select the date. And again, it will ask you the type of data. It will ask you the type of data that you are having. And then, but for in our case, we don't have this situation. So our variable, selling price is what? Selling price is a numeric variable. So we can stick to the numeric there. And then the next one is say, how big is your value that we're expecting there? Is it more than eight numbers? So we can leave the 8 there. Whatever value that you want to put under selling price is having some decimals. If yes, indicate. If it's only one decimal, you can use these arrows there to change the what? To change the decimals. If it's not doesn't have decimals, you can make it 0. So this one here under label, with SPSS, when you define your name, it doesn't allow you to have a space in between. Like, for example, the selling price of the house. You see, we have the selling, and the selling is one weight, price is one weight, off is one, and then of the house. So it doesn't allow you to write it in full under the name here. So when you go to the level, now you can write it the way you want it. You can say selling. Now you can say what? Selling price. You can have a space now. So whenever you run the result, what will appear on your result is this information. Well, this one, cell P, it won't appear, but if you don't define your label here, it will bring this name the way it is. But if you want someone to understand your result, it means you have to indicate that as cell P means selling price. Same applies to the age. Age is still the same. You can say age of what? Age of the house if you want. The size of the house. It allows you to write to define the variable the way you want it. Do you understand, guys? Do you follow? Okay. The challenge is I cannot see you guys, so please, as I indicated, I'm not using my laptop, so I'm not familiar with this guy's laptop, but I will try. So the value there, this one is applicable. Value label, it's applicable if we have a categorical variable. Like, for example, let's add another variable, call it what? A swimming pool. Swimming P, representing what? The swimming pool. Swimming pool what? We want to make it numeric. We want to make it numeric, guys. That a house with a swimming pool, we'll call it what? 1. And the house without the swimming pool, we call it 0. Swimming pool. Now we can write it in full there. So when coming, because this variable is categorical, you have to define it, provided you change the variable to what? To numeric. If we change the variable to numeric, it means we can define now. We can define that under value label. We can define, say, 1. If the house having what? We indicate if the house having a swimming pool, and then we add, and 0 if the house no swimming pool. Now we're defining that categorical variable. So this variable this part you can only define it provided you are having a categorical variable that you want to what? You want to assign to some dummy variables. Whenever we're talking about dummy variables, this is the part where you can deal with the dummy variables. swimming pool. So suppose we have only these options. You add them and then you say, okay. So your data set, we're expecting the selling price of the house with 3 independent variables, which is age, size, and swimming pool. Do we have missing observations in our data set? No, we don't have. If we have them, we have to specify. So based on this information, let's go back to the data view. You see now what is happening. It's telling you that you'll have variables. So here we can change to a scale. You know this one from first year. The other one, this one is swimming pool. It's an ordinary variable. It's nominal, right? It's nominal. So we can change to nominal. Even if you don't change the measures there, they won't affect your results. So now, let's go to the other page now, to the data view. And now, let's capture the data set. So you can export the data set, or you can capture it direct from SPSS. If you want to export, you will say File. When you want to export, you say File, Import Data. Can you see this part, guys? If you have your data is ready in Excel or SPSS, you will say File. You say File, and then you move to Import. It will ask you the data that you want SPSS to run is from where? Is it from Excel? Is it from CSV? Is it a text data? Is it from SAS? Is it from Stata? So you must choose. If you choose Excel, it means now SPSS is expecting something from what? From Excel. If you have them from the desktop, for example, let's say I choose Excel. If I choose Excel, it will take me to the desktop. You see, it's reading data from what? From Excel, because I chose Excel. If I choose a different, I decide to choose a different thing, maybe CSV file, it will show me the CSV files. So it's only showing me the folders from the desktop and the Excel files. So, but in our case, we don't need that. Let's just type a data set. Let's just come with 10 values. The selling price of the house, let me just come with 10 values at random. Let's say this one is 20,000, 10,000, 34,000. Oh, sorry. 24, 23,000, 34,000, 40,000, 30, 60. I was just coming with these values. 11,000. The age of the house is numeric. So we'll say the house with 0, where 0 is indicated, it means the house is less than 1 year old. The size of the house, let's take is 3, 1.2, 1.4, 2.2, 2.3, 1, 2, 4. I'm just coming with these values at randomness. Now I want to check if the house is having a swimming pool or not. Here we're expecting what and what? Zeros or 0 or 1. No swimming pool, no swimming pool, no, no, no. I'm just capturing these values at randomness. I'm not having any specific reason why this one is 60,000. Let's say this one is having the swimming pool. So now here's our data set, guys. And now if we want to run this data set, there are a lot of things that you can run from SPSS. For example, If you want to run, you want the what? You want the scatter plot, you can do that. If you want the check the relationship between y and the independent variables, you can do that. Let me show you about the scatter plot. You go to graphs, then you choose there, you just legacy dialog, and then you choose what? Scatter plots. It will ask you what type of scatter plot are you looking for. You know you are looking for, because you want to check for the relation between the selling price, the age, the selling price, and the size. Let's choose this one. So with SPSS, you just, it's a point and click software. So whatever you want to run, you must tell SPSS that, can you please give me the scatter plot of this variable and this variable. So suppose you want to find the scatter plot between size and age, and between size and between selling price and age, between selling price and size, and between age and size. So you just give the software that information, and then it will give you the results. Can you see the results, guys? Can you see the results? Yes, if you can check these results, guys, wherever they intersect, it means you can check for the relationship there. Can someone tell me the relationship between size of the house and the selling price of the house? What is the relationship there between size and the selling price of the house? You check where size and where the selling price, where they intersect. In that box is the relationship between X and Y. What type of a relationship are you seeing between X and Y? Between selling price and size of the house? Come on, guys. Guys, let's communicate. What is the relationship there?
Is it linear relationship? Is it linear relationship?
Yeah, selling price of the house seems like there's no relationship between it, because we don't see any relationship there. What about between selling price and age? Selling price and age, you have selling price, here it is, and the age, where they intersect. We're talking about this plot. How is the relationship there? Or is this one, sir? How is the relationship here?
Also linear.
It's linear, but, and we also suspect that we're having an outlier, isn't it? We also suspect
Yes.
that we have an outlier looking at this observation here. We suspect that we may have an outlier in our data set. So what about the correlation between independent variables? What we'll be checking by doing so? Correlation between independent variables. What are you checking? Correlation between explanatory variables. Sorry?
Strength.
Yes, I mean, what are you trying to assess by checking the relationship between the independent variables? You are trying to check for multicollinearity, right? So you are checking for multicollinearity there. You can tell from that plot, can we say age and size are related? Look at the plot which goes with age and size. Can you say they are related? I'm waiting for your answer, guys, before I can continue. I'm talking about this plot here. This plot. This plot. Do you notice any relationship between X and Y here? No. So it means we're fine.
There's no relationship between those two.
Yes. And if you want to go back to the data set, you see from the ribbons there, you see there's one which is like it's a star. You see a star, just click on that star. It will take you to the data set. Again, before I forget, if you want to check if under swimming, the way you define your values is correct, you can click what? Next to help, there is this two arrows. The other one is saving 1. The other one is saving A. When I point on it, it will say value labels. If I click on it, you see what it's doing? It's able to define what is written under swimming. Whenever the system sees 0, it knows that I defined it as what? A swimming pool. Whenever it sees 1, no swimming pool if it's 0, 1 if we're the house having a swimming pool. So if, suppose I made a mistake, I typed 2 by mistake. Let's take even here, I typed 2. When I click there, it will tell me that there is another value that is not defined. You see, there's a 2 there. It means it's failing to change that to letters because it is not defined under what? Remember, I defined this. It's not defined here. You see, we don't have a 2 here. So even the system is confused. It will leave that value as 2. So it is very, very important when you, before you run the results, check if you captured your data correctly. So moving. So let me go back. So it means, remember here we said this what? This one. Even here we said this 1. So now let's say you want to run the model, because that is the main point. When you want to run the model, you go to analyze. It's part we say analyze there. If you can click analyze, there are a lot of things that you can do, guys. There are a lot of things that you can do. You can have a descriptive statistics. If you want to find a descriptive statistics, you can tell the system there that please, I want the descriptive statistics of the following information. Just select. It's a matter of selecting. You tell the system that please, for my data set, give me the variance, give me the range of my values, give me the standard error of the mean. It will give you everything that you are asking. So if you see, click OK, you see the table that is given now. The system, whatever you ask the system to do, the system will do that. So what is funny, even if you ask the system to give you things which does not make sense, the system will give you. So it's your responsibility to run what? Like, I cannot find the mean of a categorical variable. It doesn't make sense. So I didn't select it because if my results are having the mean of gender, there's not division of gender, it doesn't make sense. You cannot find the mean of categorical information. You cannot find the variance of categorical information. But you can use that information to do what? To draw the graphs, to find the frequency table, and so forth. This one is basic statistics. So you just have to go back to first year notes and revise. So now our main focus is on what? On the regression part. So regression, you have, remember our module is applied linear regression. So you move to what? To the second one, the one written linear. Linear R is linear regression. You just click on that one. It will ask you that please define your dependent variable. You just click on that dependent variable. There's an arrow there. You transport it to what? To its destination. The destination is to be what? Supposed to be what? To be a dependent variable. And then also, there is a cell where you have to put what? Independent variables. So if this value is there by mistake, you can just take it back. In, out. So These other three, they are what? Independent variables. So they belong to what? To the other cell. So you just put them to the other cell. So remember that when we are doing chapter 5, I indicated that we have forward elimination method, backward elimination method, and so forth. And I also indicated that you can indicate the alpha to remove and the alpha to stay. So when you click this part with certain method there, click the arrow pointing down, it will ask you that when you want to run these results, which method do you want the system to apply? If you don't want any method to be applied, you just leave it as enter. If you want backward elimination method to be applied, you select backward. If you need stepwise, you will select stepwise, and so forth. And then another one that the leaders were asking is about the option. You remember that from your special optional test, there was a question which was asked that when applying backward elimination method, do you need alpha for entry and alpha for removal? So here it is here. So you can decide if you want to run your result using 5%, it means you have to come here and change this to what? To 5%. If you want to run your results using 0.05%, 0.01% to enter, come and change. You have to change this too. Remember when I was talking about significant level for entry and significant level for staying. So this information is applicable when you are using what? When you are using those methods, the backward elimination method, the forward elimination method. So if you use the backward elimination method, you know the alpha that is important is what? Is the alpha to remove. If you use forward elimination method, you know the alpha that is important is what? Is alpha to enter. You know when you use stepwise elimination method, the alpha that is important is what? Is to end, is the one for entry and for removal. You know the theory behind these things. There's no need for me to explain in detail. So you can decide there. So again, with SPSS, if you want the system to store something for you, you have to tell it. For example, if you want SPSS to give you the leverage values, it will give you. If you want SPSS to give you the prediction means for all the values in your data set, it will give you. The individual is the prediction confidence interval for Y. If you want to change the percentage here, you can change to 95 if you want. But remember, if your confidence interval is 95, you want to use it for what? Maybe confidence interval of the betas is 95. It means if you want to use that for removing some of the variables, make sure that even the alpha when you are testing for the overall model is also 5%. If you are using the confidence interval, 90% confidence interval, it means even when if you want to use that confidence interval to remove some variables, make sure that even when you're testing for the overall model, you are using what? A alpha which is related to that confidence interval. So again, if you want the system to store the standardized errors, it will store it with what? But the difference with this SPSS and SAS, this one, whatever I'm selecting here, it will go and join what? It will join the data set. So your data set now you will find it with what? With this extra information. So this one is not going to the results. Whatever I'm selecting here is, if you can check up there, it says linear regression save is going to save whatever I selected here with what? With your data set. Leverage values is going to store the leverage values what? Next to your data set there. So assuming that, let me not select this because we won't need them. Let me select the leverage values, mean, individual. So I say continue. What is left now that we didn't last is what? We need the VIF, right? Remember about the VIF method? I'm looking for the VIF now. Statistics, maybe I missed it. There's collinearity here, diagnostic. There is covariance matrix. There is confidence intervals for the betas. This one now is confidence interval for the betas. The Benoit-Weinstein test, you know how to apply the Benoit-Weinstein test if it's applicable in our problem. The descriptive statistics, you can select if you want them. And then let's say continue. But whatever I selected now for this one, it's not, it's to be what the system is going to give you the results. So now let's go to the output. So let's check. We ask the system to give us the following information. Descriptive statistics. It says that the selling price, the average price there is 32.4. And then the average age of the house is 4.4, and the average size of a house is 2.29. But the last one, I selected it by mistake. Does it make sense? What does it mean when it says the average mean is 0.6? So you cannot have a descriptive statistics for what? For a quantitative, a qualitative variable. So now, this matrix, the next one, this is the correlation matrix, is the one which shows you the relationship between selling price and age, selling price and size. You can see the relationship there, but there's a strong positive relationship between the selling price of the house and if the house is having a swimming pool. And again, you can also check the relationship between independent variables. So that one is clear there. Let me go down. Now, the system will indicate that variable, the method used is the enter method, which means the system is just going to run the results for you. It's not going to remove any variable. So let's check. Model summary, it shows you the what? The R there, correlation coefficient. What did I say about this R in multiple linear regression? What can you say about this 0.866 in multiple linear regression? What did I say about it?
Can interpret.
There's no need to interpret it, guys, because it doesn't make sense. But the R squared you can interpret. The standard error you can interpret. The Benoit-Weinstein value, you know how to use it. It means for you to check if there's autocorrelation, you can, that D 3.053 is the Benoit-Weinstein calculated value. So it means when you want to go to the table, you will check, you're going to check for what and what from the table. You have 3 independent variables. How will you check for the Benoit-Weinstein? When you go to the table, you check for what and what. I need the 2 values that will be used to check the value from the table. Yes, your data set. The answer is from here. What will be your should I call it V1? Remember, I explained this yesterday. I said you count the number of independent variables. In our case, we have 3. So it means you'll check for 3 and what? and 10. 3 and 10, then you select the value. And with the Benoist, remember you must take two values from the table, the lower limit and the upper limit, and then you do those comparisons. So before I go back to the data set, I explained that whatever I selected from that table, the system will store it. The system will store the information under what? Together with the data set. So, guys, I want you to use this information. Yesterday, if you recall very well, guys, I told you what? I said in multiple linear regression, if you want to find the leverage values, you will multiply matrix X with the inverse. Again, you multiply whatever you get with what? With X transpose. But our focus is on the diagonal line, which means this first value here is H11 is equal to that. The second value is H12. The second value here is this one is H22. This one is H33. This one is H44. The last one, it will be H1010. Means here we're talking about the values that are supposed to be on the diagonal line of that matrix. If we are having 10 values, like in our case, you'll have a 10 by 10 matrix. But your focus is on the diagonal line. So to assess if we're having a problem from the first row, if we're having issues with this row number 10, it means you are going to check if is there any value here which is greater than 2h bar. Can you please check that, guys? Let's find 2h bar. What is the value of 2h bar? 2h bar, you have the data set there. You know the meaning of P. You know you have your N. So calculate 2h bar and tell me if we're having an influential observation in our data set. Remember, we said we suspect there's an outlier. That outlier that we suspected from the scatter plot, is it influential? Please check it for me. Christopher, 2h bar. How many parameters do we have, Christoph?
We have 2.
Why 2, Christopher? Remember, you have beta 0 plus beta 1. Let me explain. You have beta 0 plus beta 1 x1. Oh, beta 0 plus beta 1 h plus beta 2 size plus beta 3 swimming pool. How many parameters do we have? Remember, with leverage procedure, when you count, you include the beta 0 when you want to count the number of parameters. What are you getting, my leader? How many parameters do we have?
4.
Sorry?
4.
4. You are right. Beta 0, beta 1, beta 2, beta 3, and what? Beta 0, beta 1, beta 2, beta 3. Yes. So how many parameters do we have? 4. So you say 2 multiplied by 4 divided by 10. What is the answer?
0.8.
It's what?
0.8.
Do we have an influential observation in our data set, and from which row? If there is a value which is greater than 2h bar, it means there's an issue there. Check for me. Under left 1, under this column, do we have a value which is greater than that?
Yes.
From which row?
9. Row 9.
Row 9. So we have an issue with row 9. So before you continue, you must first deal with what? With this influential observation. So row 9, we suspect that we're having what? We're having an outlier. It takes us back to what? An observation can be influential and an can be what? An outlier. So this one is influential, and again is a what? It's an outlier. So before you can even do the predictions of the mean and so forth, we must first deal with what? With that outlier. So if you are given a data set, you must first deal with what? With that outlier that you are seeing from your data set. So that's how you deal with what? With the outliers. So this one here, this is the confidence interval for the mean, lower limit of mean confidence interval, upper limit of mean confidence interval. That's the meaning of that sign there. This one is the prediction confidence interval. Lower limit of individual confidence interval. That is the meaning of LICI. Lower, this is the lower limit of the individual confidence interval. This one is the upper limit of the individual confidence interval. This one, it goes with what? Prediction confidence interval of what? Of Y. These two, lower limit, upper limit, the confidence interval for what? For the mean. So it's possible that we can give you these values and we'll ask you to check if we're having influential observations or not. And one, I think it's 2020, in one of my tests, I gave an output and this column was empty. I asked students why that column was empty. What happened is that I used the backward elimination method to remove the variables. And what happened is that all the independent variables were removed in the model. And remember, for you to find this leverage, you need what? You need the X matrix. So all the independent variables were removed. Remember, this leverage procedure, it will calculate the leverage values based on what? If you use those selection methods, based on the variables which are what? Which are entered in the model, if you're using forward elimination method. Or if you're using backward elimination method, it will be based on the variables that are what? That are remaining in the model. If you use backward elimination method, it will remove some, assuming that size is removed and swimming pool is removed. When the system calculates the leverage values, it will only use what? The variables that are remaining in the model. So what happened with that example? I used backward elimination method, and the system found that all the independent variables are not what? Are not important in predicting Y. So the column of leverage was empty. I asked the students, why is the column of leverage empty? Few managed to get it right. But the main reason is that if you don't have independent variables, if your independent variables are removed from the model, it means the leverage values, you won't be able to calculate them because you don't have what? You don't have X values. So let's continue. Given the ANOVA there, it shows that you have three independent variables. Now sig from SAS, it will write P. Once return sig there, that is P value. Sig dot is the P value from that ANOVA table, the last column there, that is the P value. You compare that value with what? With the alpha. How will you know the alpha? You will be guided by what? The system. So if it's not specified and it's the enter method, you can use 5%, 0.05 to make your decision. Again, this is the coefficients table. Wherever you see sig dot is the what? Is the p-value. The other ones are clear now. The t there is the t calculated. Standard and standardized betas, those are the coefficients. Beta 0.26 is beta 0, negative 1.77 is beta 1, negative 2.44 is beta 2. The beta for swimming pool is 32. And the p-values are there under the column of sig. You can see that if we use 5% to remove 0.05, only swimming pool will remain in the model, isn't it? Provided we use the enter method. If I ask you to give me the final model based on that, it means your final model will have only what? Will have only swimming pool. But if we use backward elimination method, which variable will be removed first? If we use backward elimination method, which variable will be removed first?
Size of the house.
She's saying size of the house. Let's see. Now I'm going back to my data set, run the result, and check if indeed that variable will be the first one to be removed. I'm going back to the data set, run the result, analyze again using regression. Now I want to indicate what? Indicate the method to remove. I use backward elimination method. But please, guys, don't forget what? Don't forget this part. Remember that part? It says what? Entry is 0.05, removal is 0.1, isn't it, guys? So if we want to change that, we can change it. It's up to us. If we want to use the confidence interval for the betas too, also to make decisions, it means before you go far, make sure that you do what? You specify. You go to statistics that the confidence interval that I need here, because you know that it will remove using what? 0.1. So you tell the system that even the confidence intervals give me what? Give me 90%, 90% confidence interval. I don't need 95 because I indicated that the alpha to remove is what? Is 0.1. So here you want to be flexible. You want to know that if you want to use the confidence interval to remove, you can use them, because the alpha that you used for the F tablet when you use testing for the overall model is the very same alpha that I used to construct my confidence interval for the betas. And let's check now. Let's check these new results. The other ones, for now, they're not important. Leadership, she said that the first variable to be removed will be, she said will be what? Let's check leadership. You said the first variable to be removed is what? They are all entered there. The first, this one now, it combines everything. The first model there, it says you have the 3 independent variables, which is age of the house, size, and swimming pool. You said which one will be removed first?
The size of the house.
The size of the house. Is it the one which was removed? Check under model 2, under the second part there. This part is the size still there? It's
No.
gone, right?
Yes.
It's gone. Again, another variable was removed. Why? Let's check the alpha before we move to step 3. You see, it's 0.3. Age of the house is 0.3. It's still high, isn't it? It's greater than 0.1. It was removed. The last step, the system stopped at what? At 0.003. So the final model is having what? It's having the swimming pool. And again, if it's having the swimming pool, you cannot check for what? You cannot check for multicollinearity. So even the multicollinearity part is there. Check the last 2 columns. Collinearity statistics is giving you what? Is giving you the tolerance values and the VIF values. And what I was saying about the confidence interval, check now. We specified that we need 90% confidence intervals. For you to remove the variables, you can use what? You can use, if you want to use the confidence intervals now, they also tell you that no, even if you want to use the confidence interval, you can use them. This one, it accommodates a lot of values, isn't it? Compared to this one. the one which is having the highest p-value, even its confidence interval, it accommodates a lot of values, isn't it? This was the first one to be removed based on the confidence interval, because the confidence interval which includes 0 is the confidence interval of the age of the house and the confidence interval of the size of the house. So one of these two should go, but the p-value which is the highest is what? Is for the size of the house. This one was removed. When you move to the second model 2, the only confidence interval which includes 0 is the confidence interval of the age of the house. So it was removed. The last one now is the swimming pool. So if you are asked to write the final model, you won't include the age of the house and the size of the house. Yes, my brother or my sister? I'm listening. So let's go back to the data set and check what is happening now. Let's go back. You see what the system did now? Let's check now. You see now, at first, you didn't have what? You didn't have this leverage 2, isn't it? This leverage 2 is based on the remaining independent variables. The remaining independent variables. How many parameters do we have now? How many parameters do we have? Which goes with this level 2 based on backward elimination method? How many parameters?
2.
2, because the only variable that is left is what? Is swimming pool. So we have beta 0 and beta 1. So if we want to use this, if we can check now, the what? The leverage values changed now. Remember, they were what? The first one was 0.174. Now is 0.15000. You see? Because you are having only one independent variable left in the model. But if all of them were removed, you're going to have what there? You're going to have dots like empty. There's going to be empty. So now, can you please tell me, based on the remaining information, are we worried about a certain value from the data set? Find 2H bar now. What will be your P? Your P will be what?
2.
2. So 2 by 2 divided by 10. What is the value?
0.4.
0.4. Do you have any value which is greater than 0.4 there?
No.
So we move. So it means we know backward elimination method solved some of the problems. It managed to, there were some of the variables that were removed that the ones which were causing problems. Now we can move with the data with what? With no outliers. My brother, there's someone who's talking. So same applies to what? Same applies to forward elimination method. If what? Use forward elimination method. Guys, there's someone whose mic is on. Can the leader help us to? So suppose now we want to use stepwise elimination method. Stepwise elimination method, we need what? Significant level for A3 and significant level for removal. So suppose we are given an output. Suppose you are given an output, guys. How do you know which alpha was used to remove? The first, if we use the backward elimination method, it will indicate that your alpha is 0.1. Can you see it, guys? Backward elimination method, we agree that our alpha will be what? 0.1. It's there. It's there. So don't call us when you are writing the exam and say, what is the alpha to be used? It's there. Alpha to remove is 0.1. If it's 0.05, you will see it there. So if you decide to interpret the result using 0.05, everything becomes wrong. So let me explain the last part from there. We'll be done for the day. If you want that extra class, we can agree next week. We have a special class and iron out whatever you want us to discuss. Now, this is the last one, stepwise elimination method. Remember the definition of stepwise elimination method? Guys, can you please ask the leader to
Tato, mute your mic.
I think the leader's not paying attention.
It's fine.
Tato Sarave.
Let me explain this part here. Can you please let me call you in 3 minutes? Can you hear me? Check the first table there. Because now we're using stepwise elimination method, we need to specify the alpha that was used to enter the variable and the alpha that will be used to remove the variables. You see, it's indicated there that alpha to enter is 0.05, alpha to remove is 0.1. So that is the only difference. How many variables were entered? At the first stage, one variable is there. What is that variable? Swimming pool is included in the model. The other variables were not even given a chance to enter. Why? It means they didn't meet the minimum requirement to enter in the model. So again, it means the system will only find the what? The system will only find the system will only find the leverage values for only the variables which are what? Which are in the model. Residual plots are the same. So please, guys, this type of an output, you can get it in my previous papers. Go and get one. Try to interpret it. When we meet next week, provided you want us to meet again, we discuss. You say, I've interpreted this. I need to find this paper of this year. Some of the papers, I have them. We can go to that paper. You tell us what you have done, and I will help you wherever you need help. I thank you. Enjoy. So go and get one of yes.
Say, are you not gonna help us on how to interpret the output, like one memorandum or maybe a past question paper?
How to interpret the output is what you have done in the assignment. That's how to interpret an output. But when we meet from that special class, I can explain what to avoid, because you're writing a lot of things there which are not even necessary. So
okay.
Talk to your class rep. Let's have a special class, but not on Wednesday. And then I will explain how to interpret an output. I will give you an idea on which part to know and which part to focus on. Is it fine, leader?
Yes, thank you.
Thank you, leaders. I'm attending another meeting now. So sorry to leave you early.